Alright, so we have the circular motion practice part 2. The first one says Anna is riding a roller coaster with her sister. She experiences a downward acceleration of 18 meters per second at the top of the loop and an upward acceleration of 23 meters per second at the bottom of the loop. We are trying to find Anna's sister's normal at the top and the bottom of the loop. So we're going to take out everything that we're given. So the acceleration at the top of the loop was at 18 meters per second squared. The acceleration at the bottom is 32 meters per second squared, and the mass that they give us is 35 kilograms. So again, when we're trying to find the normal at the bottom and the top, we're going to be using these two formulas, and we need to find the force of gravity, which is going to be the same for both, but we're going to need to find the net force for each of those because there's a different acceleration for both. So first of all, we can find the force of gravity, and that is going to be using this formula here, and that will be the mass, which is 35, times gravity, which is 9.8. And you're going to multiply those two numbers together to get 343 newtons. So that's your force of gravity. Now we're going to need to find the top frictional force, or the net force. And in order to do that, it is going to be this formula here. The mass times the acceleration at the top. So the mass is that 35, and the acceleration at the top is that 18. So you're going to multiply those two numbers together to get 630. And then finally we need to find the bottom net force. And again, it's going to be that mass times the acceleration at the bottom, which they give us is 32. And that's going to be 1,120 newtons. So we found our force of gravity, our net force at the top, and our net force at the bottom. So now we're going to plug it into these two formulas. So this first one is for the bottom. The bottom normal force is going to be the force of gravity, which is 343, plus the net force. And again, make sure you're using the bottom net force. So that's going to be that 1,120. You're going to add those together to get 1,463. So that is the bottom net force, and now we need to find the top. So looking at that formula, it is going to be the top net force, so that's 630, subtracted by that force of gravity, which is the 343. And that will be 287 newtons. So this is our bottom net force and our top net force. Alright, moving on to number 2. The maximum speed at which an 800 kilogram car makes a 180-degree turn is 12 meters per second. The radius is going to be 22 meters. Determine the force of friction and the coefficient of friction. So let's plot everything that we are given. So the mass is 800 kilograms. The velocity is 12 meters per second. The radius they give us is that 22 meters. And that is what we're given, and we are asked to find the force of friction and the coefficient. So the first thing that we're going to do is try to figure out what formula we're going to be using. So our force of friction we also know as our net force. So we can use our net force formulas. We don't have the acceleration, but we do have velocity, radius, and mass. So this is going to be the formula we use to find our frictional force, aka our net force. So our mass is going to be that 800. That's going to be multiplied by our velocity, and that will be squared, divided by our radius, which is 22. So again, when solving for this, the first thing you need to do is square that 12. and then bring over that radius and divide those two numbers. And so that's going to be 6.5 rounded to 5. And then the last thing you're going to do is multiply by that 800. So our frictional force, aka, our net force, will be 5,236.36 newtons. So that is our net force, or our frictional force. And then we can look at our coefficient of friction. So when we're looking for coefficient of friction, we're going to be looking at this formula here, and we're just going to rearrange it. So that's going to be the frictional force divided by the normal. So we just found our frictional force, so that's going to go on top. That's the 5,236.36. And we need to find our normal force. So whenever we're trying to find our normal force, it is again going to be this gravitational force, because those are going to be the same. So our gravitational force is our mass, which is 800, multiplied by gravity, which is 9.8. You multiply those together to get 7,840. So plug that at the bottom. So again, we have our frictional force divided by our normal force, which is our gravitational force we just found, and divide those to get 0.66 as your coefficient. And moving on to our third question. The coefficient of friction acting upon a 750 kilogram car is 0.5. The car making this turn has a radius of 23 meters. Determine the maximum speed at which the car can make this turn. So pulling out everything we're given, they give us the coefficient of friction to be 0.5, the mass to be 750, the radius to be 23 meters, and we want to find the maximum speed. So for this one, we're going to use a lot of different formulas rearranged to find the velocity. So the first thing that we are going to do is find the force of gravity. So again, we have our mass, which is at 750, and we multiply that by 9.8 to get that gravity, which is 7,350 newtons. So with our mass, multiply that by gravity to get our force of gravity. The next thing we're going to do is we're going to look at this frictional force formula. So we have our coefficient, and we just found our normal, which is the force of gravity. So we can find our frictional force, which we know as our net force. So we're going to find this one next. So our frictional force is our coefficient, which is 0.5, multiplied by our normal, which we just found is 7,350. We're going to multiply those together to get 3,675 newtons. So now that we have our frictional force, we're going to be finding our acceleration. And in order to find acceleration, we're going to rearrange this formula here. So if we had that triangle, it will be acceleration equals the net force divided by the mass. So our net force is what we just found to be that 3,675 divided by our mass, which they give us is at 750. So that's 4.9 meters per second per second. And then finally, now that we have the acceleration, we're going to be rearranging this formula here to find our velocity. So if we want to find our velocity, to rearrange that formula, it is v squared a and r. So to find our velocity, we cover that up and we know it's going to be acceleration times the radius. So velocity squared equals our acceleration, which is 4.9, times the radius, which they give us is 23. You're going to multiply those together to get 112.7. And then the last thing you want to do is take the square root, because we just want v, not v squared. So our velocity is going to be 10.6 meters per second. And that is it.